to finish it for Tuesday. But I think online in classroom, don't I have it due Wednesday? Okay, so we'll do what we can today. If I think it's able to be done for tomorrow, I'll go ahead and keep the deadline of tomorrow. But I'm just going to erase it for right now because it very well might stay the Google Classroom deadline of Wednesday. So let's just see what we can get done. Okay, sound good? What's the title of 2.1, cool kids?
Derivatives plus tangent line problem.
Yeah, we don't have our notes open yet, so go ahead and get your notes open and ready. I mean, maybe not open, but at least out and ready. Because we're going to go straight to our notes right after this. But the derivative... Okay. Okay. Who's G prime? Why did I even call it G prime? Why isn't it like G to the first or G inverse or G with an apostrophe? This is a derivative, yeah. So when I say G prime, we're not looking at a G, we're looking at a G prime, meaning if y equals G prime, and if they say G prime of 0, aren't they just asking for the y value of G prime when, you guys know function notation, right? X is 0. Isn't that the main idea of this guy? So G prime, which is the y, what's the y when x is 0? Nick, what'd you say it was? Ooh. Yeah. Did other groups figure out that it was -3? Because you're just looking at the graph and looking for the y value. Are people outside and you're waving to them? Mm-hmm. Sneaky, sneaky, sneaky. Sneaky, sneaky, sneaky. Dun, dun, dun. Go team. Okay, how about letter B? How about letter B? What's letter B? 0. It's the y value when x is equal to 3, right? Okay, now hold on. If they were to tell us that G prime of 1 is -8/3, if they were to tell us exactly what that is, which maybe we could use these 2 points to make an equation of our parabola. Every parabola needs 3 points. I guess we could use that one and that one. Anyway, if we were to make an equation of a parabola, I guess we could plug in 1 and get -8/3. But they're just telling us, guess what? This is true. Okay, cool. They're saying, what can we conclude about the graph of G, knowing that G prime of 1 is equal to -8/3? What can we know about G? AJ, what were you saying? No, nothing. Someone was talking. It was you, though. Nick.
We can conclude that it's a parabola.
Ah, here's the struggle. And here's where it gets tricky. As soon as you bring in a G prime and you talk about a G, you start thinking they mean the same thing. But are they? Who's a parabola? G prime. Would G be a parabola too? Wait, let's think about this. I know it's kind of hard because we haven't done shortcut rules yet. We have to get to section 2.2. But shortcut rules, what happens to the power when you take a derivative? You bring it down, but what happens to the power itself? Subtract 1. So if you subtract 1 to get to the prime, what did it have to be originally? It was a cubed function. Yeah. It was a cubed function. Because only a cubed function can decrease to be a squared function in the derivative. Now, all that to say, they're not asking you to say that this is a parabola so the original was a cubic, but I'm just trying to explain why Nick's answer of it being a parabola, G being a parabola, using the word it in calculus is so dangerous. Why G is a parabola is wrong. Anyway, G is not a parabola, it's a cubic function. But let's keep thinking. What can we say about G knowing that G prime of 1 is equal to -8/3? But that, like, 1 point wouldn't tell us that. Does that make sense? They're telling us this right here is -8/3. 1 point doesn't tell us that. Pause. Look at your notes. Didn't we define a derivative on Friday? Like who a derivative is, what he is? So what can we say? If the derivative is -8/3, replace the word derivative with what he actually is. Like a whole collection of stuff that a derivative is. There's a description of a derivative at the very, very beginning of your notes. Someone tell me another way of saying derivative. Slope of a tangent line. So couldn't we say, for G, couldn't we say the slope of the tangent line at what x value? Yeah, at x equals 1 of G is, Replace slope of a tangent line with something else from that box. Instantaneous rate of change. The instantaneous rate of change of g at 1 is negative 8/3. What's something else from that box? The slope of the graph. The slope of g at 1 is negative 8/3. So what does that mean? If the slope is negative 8/3, what must g be doing at 1? If the slope is negative, doesn't g have to be somehow going down? Does that make sense? Think of it this way. If you are on skis or a snowboard, whichever one you would prefer, if you're on skis or a snowboard, something that just deals with gravity, and you're on a downhill slope at a point, what are you doing? You're going down, right? If you're just pointing forward, if you're on a downhill slope, you're going down. True? If you're on an uphill slope, what are you doing? You could think going up in a sense. I mean, in gravity, you'd actually just be going backwards. But anyway, so if the slope of the tangent line, if the slope is negative, you're going down. So we could also say something to the effect of g is also decreasing at that point. But anyway, don't worry, this is just an introduction, but that's some stuff that we can tell. The derivative is negative 8/3. Cool, the slope of the tangent line is negative 8/3. The instantaneous rate is negative 8/3. G is decreasing. Okay, how about letter D? I want you guys to take a second. In your groups, talk about how would you answer letter D based on letter C. Does that make sense? Which one did you guys use? Slope of the tangent, instantaneous rate, or slope of the graph? What did you guys use? Just use that one, okay. Slope of the tangent. Well, why not? I totally agree. At x equals what? Of g is? And since it's a positive slope, guess what g is doing? It's going up, it's increasing. Good. It's not a line, it's a cubic function, but the slope is up, so it must be increasing as you go left to right. Nick?
So that's a perfectly good answer.
Perfectly good.
But aren't we just rewriting what they've already told us?
But you're showing what it means. Does that make sense? Yeah. Because at one point, if just given a point, we have no idea about the whole cubic-y thing or what it looks like. We don't know any of that, but we know at least these little clues. And in calculus, you're going to see there are forever cards having to do with just increasing, just decreasing. Here's something that's kind of tricky. Is g of 6 minus g of 4 positive or negative? Am I allowed to look at the graph and pull out points to actually do this subtraction? Why not? This is g prime. Where's g? Oh, I don't know. He's not here. Somewhere. He's increasing and decreasing. Wait. He's increasing and decreasing. His y's are getting higher or lower. Can we look and see whether he's increasing or decreasing between 6 and 4? How would we know that? Using g primes, how could we know that this is going to be positive or negative? Look at 4 and 6. Do you guys see 4 and 6? Pretend that's 6. Okay. What sign is g prime for all of those? Positive. Whenever g prime was positive, what were we saying about g? So without even seeing g, without even making a graph of g, which at this point you can't really do besides knowing it's some sort of cubic-y something, but just knowing that g prime is positive for all the x values in between here, that tells us g is increasing for all of those values. And if g is increasing for all of those values, what's going to be true at the y value later than earlier? It's going to be higher, positive. Why? G is increasing on 4 to 6 since g prime is, I will say is positive, but that takes too much time. I'm going to say greater than 0 on that interval. Does that make sense? It's true. G prime is positive. The slopes of the tangents are up. So therefore, g must be wherever he is. G must be going up. And if he's going up, well, the y value there is going to be higher than the y value there. Positive. Dun, 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 dun. Letter F. Is it possible to find g of 2? Good. Why? Why? This is G prime. That's enough for me right now. No, this is G prime. It's not G. I can't find it from the graph. This is G prime, not G. So no. You're all waiting for me. You silly goofs. No. We only have a graph of... Now, do you want to hear something really crazy? Remember, first day of calculus past the summer review packet, and you guys had... Ooh, where are they? They're up here. Remember these? What were we doing with this? Tangent line problem, the weird awkward secant lines getting closer to the tangent line. But what else were we doing? Integrals, area under the curve. You know what's crazy? Is if we were to do the little boxes here in a certain way, estimating the area under the curve, we could actually, given any sort of, just given 1 point of G, that's it. If they would just give me 1 point of G, any point, it doesn't matter. If they gave me any point of G, using those little boxes, we would be able to estimate G of 2. Boxes? Let you go backwards? That's interesting. That's integration, but that's second semester. All right. Dun, 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 dun. Notes. Isn't this what we got on Friday? Problem-solving clues. As you're getting your notes out, I want you guys to play musical chairs with someone in your group really quick. Go. Musical chairs, someone in your group. Leave all your stuff except for your composition book. Switch desks. Go. Give them high fives on the way. Musical chairs, real quick. Go, 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 go. Chinese fire drill. That works. Chinese fire drill, ending in a seat that's not your own. Just your composition book. You can grab everything else later. Or just take everything. I don't care. Just sit. You get to see what they see every day. And hopefully woke up in the process. All right, here we go. All right, coming back. Sure. Forever number 7. Wait, what did you ask? Oh, there are more cards on Share the Hope wall. Remind me tomorrow when it's not chapel day. And then I'll share them. I think we have Maggie's life verse up there, and then we have quotes from some people that have been named and some people that haven't been named. All right, on Friday, were you guys just supposed to name this card problem-solving strategies? Is that enough to clue you into what's going on? No. So tell me what the important information was. These two are both what? Okay, so they're really derivative definitions, but they're derivative definitions not of f prime of x, the most common thing left off these formulas, but instead now they're f prime of a. It's exactly what we were just seeing. We were seeing a derivative at 1, a derivative at -4. Talking about the derivatives, multiple ones, over 4 to 6. So we're making them specific. And then this, isn't it just point slope? But what got plugged in? We know that x is a, and so then we can say his y is f of a, so we can say his slope is f prime of a. So with that, let's go ahead and go, using the definition of the derivative, do the following. Let's go do the following. You have a function, x squared plus 1. It's a parabola. You have a point, x equals 2. It can be your a. And then the first question says, find the derivative. They already say f prime of x. There's only one formula to use. The only question you should be asking yourself is, do I want h or do I want delta x? Do I want h or do I want delta x? Then they say find the slope of the tangent line. Which slope of the tangent line? Oh, at 2, of course. Oh, okay. And then it says make an equation of the tangent line. Should you guys know how to use the definition of derivative to solve for f prime? Yes. So I'm going to start playing right away. Nope, I'm going to orient my board. Do you guys have the function down? X squared plus 1 at x equals 2. The first thing you're doing is f prime of x. Isn't there a forever card for that? Forever number 6? F prime of x equals. You guys like h? The limit as h approaches 0 of f of x plus h minus f of x all over h. Go while I orient my board. Bless you. There's music. Well, that was anticlimactic. Every time a smartboard rings, an angel gets his wings. What? No, h approaches 0. Yeah. Remember, every limit problem, you have to have the limit written, right? Oh, this is such a struggle. No, you're finding f prime of x, not f prime of a first. Are you trying to use the formulas in Forever 7? Don't use the formula in Forever 6. But 2 we cannot deal with. With f prime of x, we don't plug in a. The general derivative. F of x plus h. Use your formula. What are you not going to kill? Seals or puppies. Why am I saying seals or puppies? I know, but what math mistakes are you going to avoid? Distributing the negative, you're going to actually distribute it. And how are you going to not kill a puppy? Foiling the x plus h, right? Okay, get 30 seconds ahead of me just in case someone didn't get to there on their own. Because I'm using the general derivative. So I'm not using the specific one, which would be plugging in the 2 right away. I'm not doing him, I'm doing the general f prime of x because that's what they asked for. F prime of x equals, or I should say that's what I asked for. So then I was like, oh, there's no a's. Does that make sense? Why are we doing all this work? What would happen if you did plug in right away? Sure. Thank you.
Thank you.
She's very excited. Yes. That would be a much more enthusiastic yes. Guys, why am I doing all this work? Why are we even distributing? Why are we even foiling? Why not just plug in the limit? Because we always plug in the limit. It'd be 0 over 0, keep going. So we're simplifying. And what's going to always happen with the difference quotient? What can we pull out? And then we can reduce, right? When we pull out and reduce, don't we end up with 2x plus h, which equals 2x. Dun, 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 dun. So I just solved for f prime of x. And some of you that know the power rule, you're like, oh yeah, it makes sense. Hang in there, section 2.2, we can go so much faster. So f prime of x equals 2x. Did I find the general derivative? I'm going to add the little word general really quickly. Yes. But what else did they ask me to find? The slope of the tangent line. How do I do that? Plug in 2. Now, were there other ways of doing this? Yes. Look at forever card number 7. I could have, just to get f prime of 2, I could have done a definition of a derivative just for him and ignored the general derivative. But since f prime of x was written there and they were looking for it, I went ahead and did the general derivative, solving for the general derivative function. Then I plugged in 2. But you know what you were looking at is that we could have started with a bit sooner and gotten to the 4 a little bit quicker, but we wouldn't have had the derivative along the way. Now, how do I make an equation of a tangent line? It's a line! What form of a line am I going to use? Y minus? What form is this? Point slope. I need a point, I need a slope. Well, what point must I use based on the problem? Why don't some of us like this? When I say what point and I circle x equals 2, why are some of you like, ugh? Why should you be like, ugh? A point, what do you need? X and, but we only have an X. It's impossible unless you think of, oh wait, they gave a function. How do you find a Y value? Plug it in, plug it in. What's 2 squared plus 1? 5. Do you see why the forever card says this can be f of a and this can be a? If they give you X and a function, go plug in and find your Y. So this could be a equals 2, f of 2, and that's exactly how I found the 5. F of 2, I came back and said, oh, hey, plug in. 2 squared plus 1 is 5. Dun, 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 dun. And then what goes here? F prime of a. And what's f prime of a? 4. Dun, 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 dun. Now, this is a right answer. What could possibly happen if you tried to simplify? You could take a right answer and make it, you've all done that test corrections last year, at least at one point in your mathematical career, on homework quizzes and, right? So if this was a long answer problem on a test, or on the AP, guess what I would want you to do? Stop. Unless they said something specifically that said keep going. But if it's a multiple choice question, could that be in the answers? Sure, they could all be in point slope form. Or couldn't they have been simplified to get y equals? Yes. And so if it's a multiple choice question, you would have had to keep going to figure out what's going on. 4x minus 8 plus 5 is a negative 3. Pretty sure I'm right. You guys double check me. But also answers in the back of the book might be y equals as well. So could you leave it in point slope? Sure, but do you need to make sure that it matches, aka that you could get the right answer if you needed to keep simplifying? Yes. Does that make sense? Okay. In calculus, we're going to call this sticking it to the man, being like, haha, I don't have to simplify. But if you're checking in the back of the book, yes, you do, because you have to see if you were right or not. Or if it was a multiple choice question, yes, you do, or else how are you going to make it match? But anyway, long story short, equation of tangent line, plugging in a, plugging in f of a, and plugging in f prime of a. Will this be a line? Ooh, common mistake once you get used to this. Will this be a line if we put in the wrong guy? Would it still be a line if I put in 2x instead of 4? I'm putting derivative. I know the derivative is supposed to go there. I'm so smart, but is it a line? What's 2x times x going to be? A parabola? It's going to be a quadratic. So would it ever make sense to make the general or put the general derivative in the slope spot? No. Because I'm trying to make a line, and a line needs a constant, an x, and a y, and then it can be a line. If anything else is in there, it's wrong. Okay, with that, let's keep going. Terms. Oh, you can't see the top. Lo siento, un momento. Por favor. Okay. Derivative terms. Derive or differentiable? Derive or differentiate, lo siento. Derive or differentiate. This is a verb. What? You're giving grammar parts of speech? Yes, I am. This is a verb. To derive. What year was this? 3 years ago? I think it was 3 years ago. The CalcAB t-shirt. Yes, there's going to be Google Classroom assignments soon. And you guys can have a few days to post your ideas for Calc sweatshirts / t-shirts on Google Classroom, but you'll have to have some sort of electronic copy of it. You could use, what's that one where people can make their own custom ink, right? Isn't that the sweatshirt site? Or you could just put like pictures on a Google Doc and be like, hey, I want this on the front and the side and this back or whatever. Anyway, I think it was 3 years ago. The BC shirt said, don't drink and derive. Was it silly? Yes. But does it at least get the idea across, derive, like derive a car, but it was spelled like that. Does it at least get the idea across that it's a verb? Yeah. If you're driving a car, what are you doing? It's an action, right? Another one, it was the ultimate deriving machine and had like a BMW symbol, but it was churned into like calculus stuff. Anyway, that was an AB shirt from I think 4 years ago, maybe 2 years ago. Anyway, derive. Derive is a verb. Is it deriving a car? No, it's deriving a function. But either way, you are taking or finding a derivative of a function. And guess what? Derive or differentiate, same dealio. So if the directions say something about differentiating, you're not just trying to, like in English, trying to, I don't know, map out the compare and contrast and trying to distinguish what's going on. That's not differentiate in math. Differentiate means to take a derivative, to find a derivative, solving for the derivative. To derive or to differentiate. Notation. One of the most common ones is going to be d dx of whoever you're taking the derivative of. And didn't we just take a derivative of an f? Is that who we're taking a derivative of? You can put this little d dx on the outside. D dx. It means verb, take a derivative of. I'm about to derive the following function. Technically, it means take the derivative of with respect to x. Taking the derivative of f of x with respect to x. But that's going to be derive or differentiate. Differentiation. Come on, my grammarians. What kind of parts of speech is that going to be? Part of speech. Whenever you have a shun. Not an adverb. Not a verb. Oh dear, we're just throwing things out. Struggle. Differentiation. Differentiation. It's a noun. Differentiation. Differentiation. I'll try to think of another word that actually works the same. If you put a shun on the end, it's a noun instead of a verb. I'm just thinking deriving, but there is no shun. Imagine. Imagination. There you go. That's good. If you're imagining something versus imagination. Imagining would be, isn't that a participle? Imagining?
I'm not too sharp on my grammar.
Imagining? It's an action, but isn't a participle the ones with the ing? Or no? I don't know. Anyway, the act of deriving. Or, hey, or differentiating. In English? No, in math. Ay, ay, ay. Differentiable. Now, Nick. Are you the one that said this one last time? Differentiable. We said all of them. I think Ruth said this one too. Adjective. Differentiable. If you're lovable, right? If you're irritable. If you're, okay. Anyway, differentiable. It's an adjective. But the nice thing with the ables, right? It kind of works the same with all the ables in the sense of able to be, right? Able to be derived or differentiated. So what's true between deriving and differentiating? They're synonyms. Ooh, synonyms. Aren't they the ones that mean the same? Yes, not homonyms. Ooh. Or antonyms. Ooh. English day. Okay. For those that are super annoyed that that is underlined when the rest of it isn't, I am as well. I apologize. I was being lazy, but now I just can't handle it anymore. So, whoop, whoop, and whoop. There you go. Okay. The derivative of a function. We've already talked about one notation in the sense of f prime of x, but there are a few other ones. It could also be dy dx. It could also be hold on. I think it's like that. Ugh. Am I missing any? Those are the main ones. P.S. Guess what derivative is? Verb, noun, adjective, adverb? Noun, definitely the derivative of a function. But a different type of noun. Talking about the derivative itself, not just the act of deriving or differentiating. Okay, so we have some vocab. That way you guys will deal with it when you get to homework. What are you doing in homework? Using the definition of the derivative to derive or to do things like find slopes of tangent lines, to use, hey, like we did in class today, to face different questions that might be different descriptions of the derivative. Are we totally done with this section? No, but we're super, super close. Is homework due by 7 a.m. tomorrow? No, but you better be started on it. But pictures not submitted until Wednesday morning of the entire attempt. Bye, guys. Ready, break.